Dear students, today in MALP, the continuous lectures 11, our topic is how to draw 8085 architecture block diagram. Before this start how to draw the architectures or the block diagram of 8085 microprocessor, we have already discussed about the different types of buses and the different types of registers in very deep. As in previous lectures, we discussed about the various registers and its properties of the various registers. So every students must be understood very thoroughly about the different type of buses and the different type of registers, because these combinations of these registers and buses, then we can draw the block diagram and understood is the working. Today's lecture we are only the discuss about how to draw the architecture block diagram. In our university exam, every time either 8085 or 8086 architecture block diagram compulsory asking the questions about the draw diagram or explain in short. So every students must be understood these very IMP questions, how to draw architecture block diagram. I just give you some technique or methods to how to start and where to start and how it to be draw. Then after it will be different parts, its explanations and comparison with the pin diagram, because we already study about the 8085 pin diagram. So which pin number can be affected in architectures or block diagrams or where it connected. So these all the combinations of registers, buses and pin diagrams. So previous lectures will be really affected that how you can be understood this architecture block diagram. So let's start to draw the 8085 architecture block diagram. Before we start to draw 8085 block diagram, we have to know about the microprocessing unit. MPU is a synchronous to CPU. It means central processing unit. It's used in traditional computer. CPU માં જે ટ્રેડિશનલ કોમ્પ્યુટર તરીકે જે વપરાય છે તેવી જ રીતના માઇક્રોપ્રોસેસર યુનિટ પણ ઉપયોગમાં જોવા મળતું હોય છે. સો માઇક્રોપ્રોસેસર યુનિટ act as a device or a group of a device which do the following task. એવું કહેવાય છે કે માઇક્રોપ્રોસેસર યુનિટ જે છે એ કયા કયા ટાસ્ક ફોલો કરતું હોય છે, કારણ કે એને ગ્રુપ ઓફ ડિવાઇસીસ આપણે કહેતા હોઈએ છીએ. તો પહેલું છે કોમ્યુનિકેટ વિથ ધ પેરિફેરલ ડિવાઇસીસ. કોમ્યુનિકેટ વિથ પેરિફેરલ ડિવાઇસીસ મીન્સ ઇનપુટ આઉટપુટ ડિવાઇસીસ જે જોઈન્ટ થાય છે, કોમ્પ્યુટર જોડે જોડાય છે, તેની જોડે કોમ્યુનિકેટ કરવું. કોમ્યુનિકેટ બિટવીન ધ ઇનપુટ એન્ડ આઉટપુટ ડિવાઇસીસ. પ્રોવાઇડ ટાઈમિંગ સિગ્નલ. જે કંઈ પણ પ્રોગ્રામ્સ આપણે ચલાવવાનું છે અથવા તો જે કંઈ પણ સિક્વન્સમાં પ્રોગ્રામ ચલાવવાનું છે, દેટ વિલ રિક્વાયર સમ ટાઈમિંગ ઓર ધ સિગ્નલ રિગાર્ડિંગ ટુ ટાઈમિંગ, તો એ પ્રોવાઈડ MPU કરશે. દેન ડાયરેક્ટ ડેટા ફ્લો. સમવેર ઇટ રિક્વાયર્સ ડેટા ફ્લો ડાયરેક્ટલી or somewhere is required data flow is indirectly. So here is provided direct data flow. Perform computer task as a specified by the instruction in memory. મેમરીની અંદર જે કંઈ પણ ઇન્સ્ટ્રક્શન છે તે મુજબ કોમ્પ્યુટર જે છે એ ટાસ્ક પરફોર્મ કરે. This responsibility is a microprocessor unit or group of devices. So these are the functions. Now we start the draw. Here I start the 8-bit data bus. So 8-bit data bus is connected with the several registers. Here is the first ALU, then after A. So register A is the accumulator. Then I draw TR. TR means transfer register. Then F. F means flag register. So this accumulator is connected with the 8-bit data bus in bidirectional form. This indicates both side arrow, it means bidirectional form. So first I draw the accumulator transfer register, flag register and ALU. Then I will be connected with the each other. How it connected? Let's see. So accumulator is connected to ALU, then also is connected with the temporary register. Then after temporary register is connected with the ALU. Then ALU is connected with the flag. This is all are unidirectional. Then after flag to 8-bit data bus with the unidirectional, and flag is a return to ALU. So this portion is connected like that. Now I have taken a instruction register and instruction decoder and machine cycle encoder. So this will be connected with the timing and control signals. So first 8-bit data bus is connected to instruction register, then after instruction decoder, then it will be connected to timing and control unit. And here is the interrupt control. So interrupt control is connected in a bidirectional form with the 8-bit data bus. Also it is connected with the time and control signal by unidirectional. And this interrupt control signal will connected with the flag register as well as ALU. So this way we can connect it interrupt control. Then after serial input output control, this will be connected bidirectional with the 8-bit data bus. Then it also be connected with the timing and control signal, and also it is connected with the instruction decoder and machine cycle encoder. Then after registers, the different types of registers are here. So here is the registers, is the special functions registers, general purpose registers, like that. It connected with the using multiplexer or MUX with the 8-bit data bus. So bidirectional use buses for the MUX connected the different types of registers. Also they are MUX connected with the instruction registers. So this way it will be connected. Then it also the serial input output control is connected with the increment and decrement of the bus, which is a 16-bit is connected like that. And in the bottom of the register is the address buffer and address data bus. So this will be bidirectional connected with the 8-bit data bus. Here is connected to 8-bit bus data bus, and also this connected like that. So these are our block diagram. So it will be very easy to draw, but it will be some systems or systematically step by step you have to draw the lines and use the directions in each and every nomenclatures. Now I will be study here is a one by one for the part. Suppose it will be accumulator. So we are interested in each and every part and how it works. So here is the interrupt control. So interrupt controls is the various inputs and output pins. Here is the interrupt acknowledgement, RST 5.5, RST 6.5, RST 7.5 and trap. So these all the signal in and out, the pin number is connected here. Trap is a 6, 7, 8, 9, 10 and 11. So this interrupt group pin, as we earlier know in 8085 pin diagram, this will be connected. Here is the interrupt control. So here interrupt control, we can also say that here is a various control is connected in interrupt control 6, 7, 8, 9, 10. So this pin will be connected. Then after address buffer and address data buffer. So this is address bus A8 to A15, and AD0 to AD7. So this pin number is A15 to A8 to A15 is 21, 22, 23, 24, like 28. So 21 to 28 is connected between this A8 to A15 address bus of address buffer. And here address data buffer is a pin number is 12, 13, 14, 15 to 19 is the AD0 to AD7. So AD0 to AD7 pin use is 12 to 19. So here is the diagram. Here is the buffer pin. Here is it will connected address buffer and address data buffer, data bus. Okay. So this AD7, AD0 to AD7 and A pin is address bus and data bus is connected here. Okay. So this will be the address bus and address data bus will connected with the architectures diagram. Then after serial input and output form. The serial input and output form, there are two, SID and SOD. So serial input and serial output will be connected, and also the pin number is 4 and 5. So in pin diagram it is 4 and 5, and this will be connected here as a architecture input and output terminal. Same way timing and control. So timing and control, there are various input x1, x2, clock out, reset in, reset out, ready, ALE, S0, S1, IO slash M bar, RD, WR, hold acknowledgement. So this will be connected. Here is the pin number 29 to 39, and the 40 is the VCC, this time and control signal. And x1, x2 is connected with the pin diagram is 1 and 2. And reset out, here is the reset out is connected pin number 3. So this 1, 2 and the 3 connected with the x1, x2 and reset out. And this 29 to 40 it will be connected as a timing and control signal. So this way all our 40 pins will be connected with the architectures, the block diagram of architectures with the various part. So here we have to conclude that each and every pin will be connected here for this interrupt control, serial input output control. Then here's address buffer, address data bus, and timing and control signal. So these 40 pins are connected in all the peripheral output devices like here. Okay, this will be not I draw here, but it will be there is a pin number or pin diagram. But in this all the pin 40 pin, I just miss the one pin. You just identify the which pin that I will be not mention here about it is 1, 2, 3 diagrams. Okay, you can find it. Now our depth in the topic is the ALU. So ALU perform the computing function of microprocessor. માઇક્રોપ્રોસેસરનું જે ગણતરી કરવાનું કામ જે છે એ કોણ કરે છે? ALU. It includes the accumulator, temporary registers and arithmetic and logic circuit, this way 3s and 5 flag. Result is stored in accumulator and flags. So here is the block diagram of ALU. Now ALU performs the arithmetic and logic operation. કયા કયા કરે છે? તો for example I have written here this addition, subtraction, logical AND or, exclusive or, logical NOT, increment, add 1, subtract 1 or decrement, left shift, rotate left, rotate right, and the clear, etc. This will be performed by the ALU. And the accumulator, it is the 8-bit registers that is a part of ALU, and this register is used to store 8-bit data and is performing arithmetic and logic operation, and the result of operation is stored in accumulator. We already study about this accumulator and ALU, just I briefly idea given here in a architecture also. Now timing and control unit. we see that timing and control unit is a bigger part. So this is the timing and control unit, the section of CPU, and generating timing and control signal which are necessary for execution of instruction. ઇન્સ્ટ્રક્શનના એક્ઝિક્યુશન માટે હંમેશા ટાઈમિંગ એન્ડ કંટ્રોલ સિગ્નલની જરૂર હોય છે જે જનરેટ કરે છે આ યુનિટ. It used to control data flow between CPU and peripheral including memory. તો એ શું કરે છે? કંટ્રોલ ડેટા ફ્લો બિટવીન CPU અને પેરિફરલ ઇનપુટ આઉટપુટ ડિવાઇસીસ અને મેમરી જે છે એ અને CPUની વચમાં જે કંટ્રોલ ડેટા ફ્લો છે એ જોવામાં આવે છે. Then it is used to provide status, control and timing signal which are required for operation of memory and input output devices. તો એ શું કરે છે? એ આપણને સ્ટેટસ પણ આપે છે, કંટ્રોલ અને ટાઈમિંગ સિગ્નલ which are required for the operation of memory and input output device. ઇનપુટ આઉટપુટ ડિવાઇસીસના મેમરીના ઓપરેશન માટે હંમેશા સ્ટેટસ જોઈતું હોય કે કંટ્રોલ એન્ડ સિગ્નલ એ આપણને પ્રોવાઈડ કરે છે. It used to control the entire operation of the microprocessor and peripheral connected to it. એની સાથે જોડાયેલા તમામ પેરિફરલ અને માઇક્રોપ્રોસેસરને ઓપરેશનમાં કંટ્રોલ માટે મદદરૂપ થાય છે. Thus we can see that the control unit of a CPU act as the brain of the computer system. કોમ્પ્યુટર સિસ્ટમનું બ્રેન તરીકે કામ કરે છે timing and control unit. Now data and address bus. So in Intel 8085 is a 8-bit microprocessor આપણે જાણીએ છીએ, and it has a data bus is 8-bit wide. એ ડેટા બસ કેટલી છે? 8 bit છે. તો 8 bit of data bus can be transmit in parallel or to the microprocessor. And address bus કેટલી છે? 16 bit. So memory address are 16 bit. And 8 most significant bit of address are transmitted by the address bus is A8 to A15. એ already આપણે જોયું છે. અને એવી રીતના સિગ્નિફિકન્ટ બીટ, લિસ્ટ સિગ્નિફિકન્ટ બીટ જે છે એ AD0 to AD7 જે આપણે જાણીએ છીએ. Now instruction. Here we carefully understood that instruction of computer is the command give to the computer to perform a specified operation on given data. જે ડેટા આપણને આપવામાં આવ્યા છે તે ડેટા ઉપર સ્પેસિફિક પરફોર્મન્સ જે બતાવવાનું કામ છે એના માટે જરૂરી કમાન્ડ જે છે એને આપણે કહીએ છીએ ઇન્સ્ટ્રક્શન. એટલે ઇન્સ્ટ્રક્શન આપવામાં આવે છે કે કઈ પ્રકારે આપણે ઓપરેશન કરવાનું છે. Some instruction of Intel 8085 microprocessors are, for example, MOV, move MVI, move immediately, LDA, load the data in an accumulator, store data in an accumulator, STA, add, subtract, round, then INR, MVR, etc. So many instructions are there. I just give you some simple example of a few instructions. Now opcode and operands. કોને opcode કહેવાય અને કોને operands કહેવાય એ પણ આપણે અહીંયા જોઈ લઈએ. Each instructions contain two parts. દરેક ઇન્સ્ટ્રક્શનના બે ભાગ હોય છે. એકને કહેવાય છે ઓપરેશન કોડ, opcode, and operand. The first part of instruction which specified the task to be performed by the computer is called opcode. જે ઇન્સ્ટ્રક્શન છે એનો પહેલો પાર્ટ છે કે જે આપણને કયું કામ કરવાનું છે એના વિશે આપણને જાણકારી આપે છે, એને કહેવાય છે ઓપરેશન કોડ ઓર opcode. And the second part of instruction is that the data to be operated on and it's called operand. બરાબર છે? ડેટા ટુ બી ઓપરેટેડ, જે ડેટાનું ઓપરેશન જોવા મળે છે તેને આપણે operand કહેવાય છે. So the operand or data given in the instruction may be various form such as 8-bit, 16-bit or internal registers or a register or memory location. Okay. નાવ ઇન્સ્ટ્રક્શન સાયકલ કોને કહેવાય? અહીંયા બતાવ્યું છે એક ફ્લો ચાર્ટ કે ફ્લો ચાર્ટમાં ફેચ, ડીકોડ એન્ડ એક્ઝિક્યુટ આ 3 પ્રોસેસ છે ઓપરેશનના. તો સ્ટાર્ટ ટુ એન્ડ એની વચમાં જે કંઈ પણ આ પ્રોસેસ થાય છે એને કહેવાય છે બેઝિક ઇન્સ્ટ્રક્શન સાયકલ. એટલે કે માઇક્રોપ્રોસેસર આર્કિટેક્ચર્સ ધ ટાઈમ રિક્વાયર્ડ ટુ ફેચ એન ઇન્સ્ટ્રક્શન and necessary data from memory and to execute it is called an instruction cycle. Fetch to execute, this will be require instruction cycle. Okay. And flag register. તો આપણે ફ્લેગ રજિસ્ટર પણ આપણે ભણી ગયા. હજુ પણ ફ્લેગ રજિસ્ટર માટે એક લેક્ચર અલગથી આપણે લઈશું, because flag register is always asked in the university exam, either 8085 or 8086. So we study the flag register with the example. But here I give you some idea. Conditional and unconditional bit. અહીંયા 8 bit છે, એમાં unconditional જે bit છે એ 1, 3 and 5 કે જેના ઉપર આપણને કોઈ પણ જાતનું bit output જોવા મળતું નથી. But here is the 0 number bit is a C. So if carry is generated, then CF is equal to 1. Okay. કોઈ addition કરો છો, subtraction કરો છો, if carry is generated, then it will be 1. Now here second is the P. It means the parity. If odd parity, then is 0. Otherwise 1. તો અહીંયા 0 અથવા 1 આવશે, પણ જો અહીંયા 1 આવે તો it means is even parity, અને જો એમાં 0 આવે તો odd parity. Then fourth one is a auxiliary carry. If carry is a auxiliary is a generated, then AC here is the 1. And then Z is the if the 0 result, then JF is equal to 1, then else JF is equal to 0. It means કે 0 result જો આવતું હોય addition કે subtraction માં, તો it will be 1, otherwise 0. And last is the sign. So if result is positive, then it will be 0, otherwise 1. So this is a simple technique. We will be discussed later on in very depth with the each and every example, that how it will be create here 0 or 1, 0 or 1 or 0 1, and what the happen due to the solving the sum. So now onwards we will discuss about the working of 8085 microprocessor in detail. હવે આપણે શું કરીશું, જે આ દોરતા આપણને આવડી ગયું છે એ દોરવાની પ્રેક્ટિસ દરેક સ્ટુડન્ટ્સે કરવાની છે. And if you once draw the properly, then in short I will be explain in the next lecture about the working of 8085 in a architecture, how the architectures will work or behave with the each and every pin and with the microprocessor unit. Okay, so I hope this will be understood.